A solution of cobalt-2 nitrate contains hexaaquocobalt-2 ions, which are pink in color. When some hydrochloric acid is added to the solution, the equilibrium shifts to the right. When equilibrium is established, the solution becomes violet in color. An equilibrium exists between the pink hexaaquocobalt-2 ions and the blue tetrachlorocobalt-2 ions. When warmed by the water bath, the solution becomes blue, so the equilibrium is shifted to the right. When cooled by the ice bath, the solution becomes pink, so the equilibrium is shifted to the left. Why does the temperature affect the equilibrium of this reaction? To answer this question, we must learn something about the energetics of the reaction.
Next chemical system disturbance that we will discuss is temperature. Always remember, only temperature change will alter the Kc or Kp value. Exothermic, heat release, enthalpy, negative. Endothermic, heat absorbed, enthalpy, positive. So based on this example, the enthalpy is negative. So this forward reaction is exothermic, release heat. Let's check this equation. Okay, this is negative enthalpy. So exothermic, release heat. Heat is added at the site of product. Okay, exothermic. Now, the disturbance is rise in temperature. If rise in temperature means adding heat, we will try to reduce the disturbance by decrease the temperature by absorb heat. In this case, rise in temperature, endothermic reaction is favorable. Forward reaction is exo. Reverse reaction is endo. Now the endothermic reaction is favorable, means the shifting of the chemical position will shift to the left. When shifted to the left, the concentration of PCl3 and Cl2 increase, and the concentration of PCl5 decrease. So the Kc value decrease. If we check with this one, the disturbance is drop in temperature, removing heat. So now the system will try to reduce the disturbance by increased temperature by release heat. Okay, always remember, drop in temperature, exothermic reaction is favorable, means forward reaction is favorable. Okay, so the equilibrium position will shifted to right. When shifted to right, the concentration of PCl5 increase, and the concentration of PCl3 and Cl2 means the reactant site will be decreased. Now the Kc value is increased. Okay, keep in mind, when the reaction is exothermic, heat is added at the reactant product side. If increase in temperature, endothermic reaction is favorable, so the system will shift to the left. When the system shifted to the left, concentration of reactant increase, and then the concentration of the product decrease, so the Kc value decrease. If the change is decreased in temperature, exothermic reaction is favorable, so the net reaction or the equilibrium position will shift to the right. Now we'll increase the concentration of the product and then decrease concentration of the reactant, so the Kc value increase. Temperature decrease favor an exothermic reaction. Temperature increase favor an endothermic reaction. Now, look at another example. SO2 gas produce sulfur solid plus oxygen gas. In sulfur, because sulfur in solid state. Okay. And then this is positive value, means the forward reaction is endothermic. The forward reaction is endothermic. The reverse reaction is exothermic. Okay, now let's check what is the disturbance for this case. Rise in temperature. If rise in temperature, right, means endothermic reaction favorable. So endothermic, again, we know that the shifting or the equilibrium position will shift to the right side. Okay, so we try to reduce the disturbance by decrease the temperature by absorb heat, and then endothermic reactions favorable shift to the right because endothermic. When the reaction shifted to the right, the concentration of oxygen increase. Okay, means the concentration of product increase, and then the concentration for the reactant decrease. Okay, oxygen increase, okay, directly proportional, so the Kc value increase. Now we check using the same chemical equation but drop in temperature. If drop in temperature is exothermic. Okay, now we try to increase the temperature by released heat. Okay, exothermic reaction is favorable, so the shifting of the reaction is shifted to the left. The equilibrium position will shift to the left, and then now the concentration for SO2 increase, means the concentration of reactant increase, the concentration of product decrease, so the Kc value decrease. Okay, always remember when the reaction is endothermic with the positive enthalpy, so the heat is right down at the reactant side. The forward reaction is endothermic and the reverse reaction is exothermic. We have to check the change. If change increase temperature, endothermic reaction is variable, so shifted to the right. If decrease in temperature, exothermic reaction is variable, shifted to the left. If shifted to the right, the concentration of product increase, so Kc value increase. If shifted to the left, the concentration of the product decrease, so Kc value decrease. Always remember, temperature increase favor an endothermic reaction. Let's check this exercise. We have to predict the effect of decreasing in temperature. Decreasing in temperature means exothermic reaction is favorable on the amount of product. Okay, in the following reaction, explain. Let's look at one by one. A, the enthalpy is negative, means is exothermic. So heat is added over here. Okay, now we check. Okay, just now is decrease in temperature, right? So we try to reduce the disturbance by increase temperature by release heat. Increase the temperature, release heat, and then drop in temperature is exothermic reaction variable. So exothermic. So the system will the equilibrium position will shifted to right, and then the amount of product increase. We have to answer according to the question because the question just asked about the shifting and then the amount of product. So the amount of product for this case CH3, CHO increase. Ignore because both of them are liquid. So here is the gas, here gas. Okay, negative again, so release heat, exothermic. So heat is over here. So forward reaction is exo, and then reverse reaction is endo. If drop in temperature, okay, remove heat, we will try to increase the temperature by release heat. Okay, since drop in temperature, exothermic reaction is variable. Exothermic means the equilibrium position will shift to the right. When shifted to the right, the concentration of H2O increase. Means amount of product increase. Okay, let's check for this one. Again, this is exothermic over here. Heat is over product side. Release heat. Okay, if the temperature decrease, okay, we will try to increase the temperature by release heat, and then drop in temperature, exothermic reaction is variable, so the shifting is shifted to the right. Okay, the concentration of the product means CH3, CHO increase. This one is endo. Endo absorb heat, so the heat over reactant. Okay, heat over reactant. When temperature decrease, okay, when temperature decrease, okay, exothermic reaction is variable, so exo is reverse reaction, so the shifting of the equilibrium or the equilibrium position will shift to the left. Okay, shifted to the left. When shifted to the left, the concentration of the product decrease. So the amount of NO2 or the amount of product decrease.
Changing
This is a summary in explanation for temperature. So the disturbance is either rise in temperature or add heat. Then we try to reduce the disturbance by decrease the temperature by absorb heat. Okay. Or drop in temperature or decrease in temperature will remove the heat. So we will try to reduce this disturbance by increase temperature by release heat. So this is the first 2 points, disturbance and reduce disturbance. And then equilibrium position, we have to determine whether the equation is exothermic or endothermic. Okay, we have to always remember when rise in temperature, endothermic is favorable. If drop or decrease in temperature, exothermic reaction is favorable. Then only you determine the shift of the equilibrium position based on the equation. And then for sure, the Kc value will be changed because the only factors that will affect the Kc, Kp value is temperature. If the Kc value increase, means the concentration of the product increase, the concentration of the reactant decrease. If the Kc value decrease, because it's due to the concentration of product decrease and the concentration of reactant increase. Okay, so always have to check the enthalpy is positive or negative. If positive, endothermic. If negative, exothermic. That's all for this video. Hope you all enjoy. Don't forget to subscribe, like and share this channel. Thank you.